Welcome back to the deep dive. Today, we're jumping into a real physics problem in large-scale satellite TV distribution.
A big one.
Yeah, we're looking at how the Thor Broadcast F-LB61 system uses light, literally light, to get around the old limits of copper wire. Our mission here is to unpack this pretty technical solution. It's designed for, huge corporate campuses or high-rise buildings, and we want to see what makes it tick.
And you have to understand the core problem first. When you're installing satellite systems, there's this really strict rule.
Okay.
The antenna itself can't be more than 100 meters away from the main equipment, like the multi-switch. For any big building, it's just not possible.
Right. 100 meters is nothing in a skyscraper. So that hurdle seems almost impossible with traditional coax cable.
Okay.
How does this LB61 system just completely shatter that limit?
Well, it basically throws out the copper. It creates a direct link from the antenna using a single strand of single node fiber.
Just one strand.
One single strand. And what that means is that the distance limit, the 100 meters, it's just gone. We're talking kilometers now, not meters.
Okay, but what about the equipment on the other end? We read that the signal that goes in is identical to the signal that comes out. It's 100% transparent.
Mm-hmm.
So does that mean a standard DirecTV or Dish Network box has no idea it's connected to this complex optical link?
It has absolutely no idea. And that transparency, that's the whole magic trick. The RF signal, the voltages, everything is replicated so perfectly that the box just thinks it's plugged right into the dish.
So you don't need any special proprietary receivers?
Nope. It saves a ton of money and complexity for the installer. The system basically hides the entire fiber network from the end user's equipment.
So once you've solved distance, the next problem is always scale. I saw that a single one of these transmitters can feed up to 32 receivers.
That's right, using a simple optical splitter.
So how do you push that much information, specifically 6 separate RF feeds from satellite dish, down one tiny little strand of glass?
Ah, that's where the really cool tech comes in. It's called Coarse Wavelength Division Multiplexing.
CWDM.
CWDM.
Yeah. The easiest way to think about it is, don't think of the fiber as one pipe. Think of it as a 6-lane highway. Each lane is a different color, a different wavelength of light.
I see. So each signal gets its own lane, and they don't interfere with each other.
Exactly. And that lets you carry the 4 main LNB signals from the dish, and it even leaves room to carry other things.
Like what?
Like local broadcast channels. The system has this huge frequency response from 54 up to 3,000 megahertz, so you can inject a local antenna feed right onto the same fiber.
That is a lot of integration. You're replacing 6 big, bulky copper cables with one tiny fiber strand. Now, what about controlling the dish itself? It still needs power and instructions, right?
It does. And the system handles all of that. It sends the 22 kilohertz control tone. It supplies the LNB power, either 13 or 18 volts, whatever's needed. It's all self-contained.
It even has a little LCD display for the installers, right? To check power levels. It does, yeah, for RF input and optical output. But there is one really critical detail for anyone putting this in, a real gotcha if you miss it. You have to use SGPC connectors. That stands for angle polished connector. That angle on the fiber tip is essential to stop light from reflecting back into the laser.
And if it reflects back?
It can damage the laser and just destroy your signal integrity. So that one detail is crucial.
So let's put it all together. What this really means for, say, a building manager is that for around $6,500, you get this incredible flexibility. You can deliver perfect TV signals across a huge campus, all by just switching from copper to a single strand of light.
Right. And what's so impressive is how it hides all that complexity. You can totally rework your building's entire signal infrastructure, and nobody at the other end has to change a thing. No new boxes, no new hardware.
It's completely invisible.
Completely. And, considering how they've managed to merge 6 different signals onto one piece of glass here, it really makes you think. What other bulky multi-cable systems out there are just waiting to be simplified down to a single fiber optic link, something to chew on?